Hello, students. Previously, you learned how to graph trig functions, how to write equations from the graph of trig functions, and how to identify all the key characteristics like amplitude, period, phase shift, vertical shift. Today, we're going to see how we can use these trig models or trig functions to represent or model real life situations. There are many phenomena in real life that are periodic in nature, and trig functions are best to model those situations or those phenomena. And then once we have a model or an equation for these situations, then we can use them to answer questions. For example, if we know that our gas bill uh, oscillate, throughout the year, then I can just write an equation for the gas bill, and then I can just use that to make a prediction at in so and so month what will be my bill, in the coming year. So we're going to start off by looking at an example of a ball that is attached to a string. And if we pull that ball down, in this situation, we have pulled it down 4 inches from its rest position. If we release it, we know that it's going to oscillate up and down. Now, in real situation, we know that due to air friction, it's going to start to oscillate. The distance between the max and min will start to decrease, and those up and down movements are not going to remain the same. They will just get smaller and smaller, and eventually it will come back to its rest position. And that is more of a damped harmonic motion. And in more advanced modeling, we would factor that in. The air friction will bring that into our formula. We'll factor all those other factors into our formula. And modeling, there's just a very advanced level of modeling is done where you have a lot of factors that you could take into account and write a model. But we're keeping it simple because this is your very beginning level of modeling. And we're going to just assume that there's no air friction and this ball is going to just continue oscillate between -4 and +4, and how we're going to write its equation. So here on the right-hand side, you can see different positions of this ball as it is going up and down, and it's showing you horizontally at different times where the ball is going to be. Okay, so as you can see, it started off here at -4 and it's going to complete one cycle. It's going to come back to -4 after 6 seconds. So that gives us the period. And before we even notice the period, we notice the min and max as -4 and +4, which means the d value, which we calculate by finding the average between the minimum and maximum value, is going to be 0. So it is not, there's no vertical shift. It is oscillating about the x-axis in this case. Amplitude, which is the distance between the midline and the maximum value, is 4. And like we said, the period is 6, which we can use to calculate the b value of this equation. So b is going to be 2 pi over 6, which simplifies to pi over 3. If I'm writing a cosine graph, then I will not need to have any phase shift for this because at 0 time, it is at the minimum value. So all I have to do is use the negative before my a. So it's going to be -4 cosine of b, which is pi over 3, times x, which we here are using t to represent the x value, which is the time. If I have to write a sine equation, so I want you to think about, for sine equation, where should the graph start? Yes, the graph should start from the midline. So I'm going to use a phase shift of that's 1.5 seconds. If you have trouble reading it from the graph, then you can just divide 6 by 4 because from the minimum, the next critical point is the midline. So that is going to happen at those scale points that we used to calculate by dividing period by 4. So 6 divided by 4 is 1.5. You can use 3/2 as a fraction value. So when I write the sine equation, I can keep the b out, and then it's just the t minus 3/2, or I can distribute that pi over 3 And my equation will be d equals 4 sine of pi over 3t minus pi over 2, because pi over 3 times 3 over 2 will simplify to pi over 2. No constant here, so the d value is 0. So now let's look at an example where we are going to actually do some calculation. What you are seeing here is the blood pressure of a normal person, which you can see is oscillating between the minimum value of 80 and a maximum value of 120. So the question here is, has given us the equation and is asking us to do some interpretation of this function in terms of the period and frequency, and use it to determine the normal range. So you can see that the normal range here is the minimum is 80 and maximum is 120. If you know, we call the maximum as the systolic blood pressure and the minimum as the diastolic blood pressure. When our heart contracts, that's when the blood pressure is maximum, and when it releases, that's when it's minimum. And it should oscillate just between these two. So anything outside this range, we consider that as a little abnormal, and someone can have a lower high blood pressure if it's not in this range. So let's go ahead and calculate the average blood pressure by finding the d value here, which is the average of the minimum and maximum value, which comes out to be 200 divided by 2, which is 100. So 100 blood pressure is considered to be an average blood pressure for a normal person. And amplitude is going to be 100. We could just do 120 minus 100, maximum difference between the maximum and the midline, which is 20. And that you can see right here. Now, if you remember, we calculate B from the period. The period is going to be 1 over 80 because it completes it here, right? And I could also calculate this from the equation because I do have the value of B. So period is 2 pi divided by B, which when I divide 2 pi by 160 times pi, it is 1 over 80. So what does it mean? The period is 1 over 80 means in 1 over 80, 1/80th of a minute is when your heart completes, the heart has a 1 complete beat. So in 1 over 80 of a minute, or 80th part of a minute is when our heart completes the 1 cycle, or it beats once, and the blood pressure goes from normal to 120 and then back to normal, and lowest to 80 and then back to normal. There's another term that we use, is called frequency. Frequency is 1 over period, which in this case is going to be 1 over 80, or just 80. Now, what is the difference between a period and a frequency? Period is how long it takes for a function to complete 1 cycle, and frequency is how many cycles we can have in 1 unit of time, which here is minutes. So 1 minute, in 1 minute, frequency is 80, means our heart beats 80 times in 1 minute. Okay, this is for a normal adult, a normal person's graph of blood pressure, and that shows that it completes 80 cycles in 1 minute. So the period is 1 over 80. Hopefully this was helpful, and the minimum and the maximum values translate to the systolic and diastolic blood pressure. Now let's look at another example here. We don't even have a graph, so in this case we're going to make a graph as well, and we're going to figure out the equation and then use that to answer a question. So let's read this scenario. We have outside temperature over the course of a day can be modeled as a sinusoidal equation. Suppose the temperature varies between 47 degrees and 63 degrees during the day, and average daily temperature first occurs at 10 a.m. How many hours after midnight does the temperature first reach 51 degrees? So if I first go ahead and draw this, because they're saying it is a sinusoidal function, the temperature is ranging between 47 and 63 degrees, and it reaches its mid average daily temperature, which is going to be the midline, at 10 a.m. Okay, this is the situation that I have. So that first gives me the minimum value of 47 and the maximum value of 63. I'm going to go ahead and find the average between the two. Which comes out to be 55 degrees. Okay. And it's going to oscillate between the min and the max. That's how it's going to go. And obviously it's going to go here as well. We just don't have that part of the information on the graph, but we know that it's sinusoidal. So it should continue with this pattern forever and ever on both sides of the x-axis. So now let's go ahead and try to write an equation. Since this is an average daily temperature, our period is going to be 24 hours, which give us the B value as 2 pi over 24 or pi over 12. So I have the A, which is 63 minus 55 as 8. So I pretty much can easily write my sine equation as y equals 8 sine of pi over 12 t minus 10 plus 55. If you do want to write a cosine equation, you could start from here. How do I figure out what that next point is? I could just divide the period by 4. So 24 divided by 4 is 6. That means at 10 plus 6, which is going to be 2 p.m., is going to be at the maximum. So I could just say y equals 8 cosine of pi over 12 t minus 6 plus 55, right? But I'm just going to go ahead and stick with this equation and figure out when does the temperature reach 51 degrees first time. So 51 degrees is below 55, so it must happen right here, right? Somewhere right here is the point that I want to figure out. I could just put 51 here for y and solve for x. For that, I have to use the sine function, the inverse sine function, which we really have not done yet. So I can just tell you that you can solve for t by first subtracting. Let's first subtract 55 from both sides. And then divide by 8, just negative half. Then you do the sine inverse of negative half. Sine inverse of negative half is kind of ahead of time. We will talk about the inverse sine function, but you are, just to quickly tell you, that you are looking for the angle for which the sine value is negative half. So that angle is going to be, you could just say negative pi over 6. I'm going to just not put the sign here because sine and sine inverse on this side will just cancel out. Pi over 12 times t minus 10. Then you can just cancel the pi on both sides, and times 12 will give you negative 2. So t equals 8. So that means at 8 a.m. is the time when it should be 51 degrees the first time after midnight. I'm going to show you how you can also find this answer on Desmos. So let's look at Desmos quickly. Okay, so let me open Desmos here. I already have the equation. I can literally just scroll through this and see where it first becomes 51. And we can see that point is, I just passed it, is 8 a.m. right here. Or you could also just graph y equals 51 to just read that point easily right here. Okay, because before that it's 51 at 0, but after midnight it happens at 8 a.m. Okay, so now let's look at some more questions here. So I'm going to pause here and let you all determine the minimum and maximum value, and hopefully will help you to figure out the amplitude and period as well. So first, let's go ahead and find the minimum and maximum value. Read the question and identify the minimum and maximum value. Hopefully you figured this out. So this is a Ferris wheel, which is starting at the minimum height is 2 meters above the ground, and the maximum it goes is 22 meters because its diameter is 20. Okay. Okay, so our minimum is 2 and our max is 22, which give us the D value by taking the average as 12. Okay, so what we have here, we have to figure out the amplitude, and it completes one cycle in 6 minutes. So I'm going to pause again and let you identify figure out the amplitude and the period. Okay, hopefully you figured out that the amplitude is the distance between the midline and the maximum, or midline and the minimum happens to be 10. Period is 2 pi divided by 6, which is pi over 3. If I am writing a simple cosine function, let's say someone is starting off at the minimum point, Ferris wheel's at the loading platform, which is at the minimum point at 6 o'clock. So I can easily write and that person is moving along this wheel. So the height is increasing, reaching the maximum, then decreasing, reaching the minimum, and this will be a movement going like this, right? That will be the graph for the position of anyone who's sitting on it. So since we're starting at the lowest, I'm going to say negative 10 cosine of pi over 3t plus 12, and that is my equation. And I need to know, I can now use this equation to answer any questions. I need to know how long does a person spend above 13 meters. So like this is 13 meters height. So how long does the person stay above this height is basically the length of this this cycle here, or the length of, the time it takes to go from this point to this point. So I am going to, we could solve it by setting equal to 13 and have two solutions and figure out the difference between the two. But let's just go ahead and use Desmos and quickly answer this question. So here I'm going to type this function. I have y equals negative 10 cosine of pi over 3x plus 12. And in order to figure out where it's going to be 13 meter, I can simply, sorry, I know that you guys can see all this writing on it, but I don't want to erase it as well. So I'm going to just graph here y equals 13 and find those 2 points. So first it's 1.596. And the second I see is 4.404. So the difference between the two is our answer. So 4.404, I believe it was. And 1.596 is how many seconds it stays above the ground. Go ahead and calculate this. So that comes up to about 2.808, which is about 2 minutes and 49 seconds. That person, is this in minutes, right? Yeah. 2 minutes and 49 seconds is how long that person stays above the height of 13 meters. Hopefully this was helpful. Thank you.